Oh, yeah.
Are we going?
Yes, we are. But we're going to start with this. So we have gotten to what everybody feels is perhaps their favorite. I think it's probably your most familiar thing. This is the most common method or form that is presented in middle schools, I think, from what I can tell.
I love this.
We're going to talk about slope-intercept form. We're going to talk about a couple different aspects of it.
So fun.
So, with slope-intercept form, I think it's pretty important for us to understand a couple things about it. Number one, what it is, and number two, what it tells us, right? So, what it is and what it tells us. So, first of all, slope-intercept form is this right here, y equals mx plus b. Let's note a couple things about this. One main thing, do you notice that for this, for a linear equation to be in slope-intercept form, one of the variables has to be by itself completely. Which variable is by itself? Y. So in other words, in order to be in slope-intercept form, y has to be by itself. If y is not by itself, oops, I missed there. That's not that you have a problem, it's that you don't have slope-intercept form. And so if y is not by itself, you can't use whatever you have to tell you the slope and the y-intercept. Does that make sense?
Yep.
You can take any linear equation, it doesn't matter how simple or complicated it is, you can take any linear equation and put it into slope-intercept form. You can. You can also take any linear equation and put it into standard form, which we use to find intercepts earlier. All right? So it just depends on what form it is. That's going to inform what you can tell about it. So let's talk about what this slope-intercept form tells us. It tells us the slope, and it tells us the y-intercept. So if I did have something like this, y equals mx plus b, if this is going to really truly tell me the slope, which letter represents the slope?
M.
M. Let me do a better M there. M tells us the slope. And B tells us?
Y-intercept.
Yeah, where the line crosses the y-axis, also known as the y-intercept. So M always goes with slope. B always goes with y-intercept. So let me just give you maybe one or two pretty simple examples, and let's see if we can decipher what the slope and the y-intercept would be. So here we go. What if I told you that you had y equals 2/3 x plus 6? Y equals 2/3 x plus 6. It's a linear equation, right? Because it's y to the first and it's x to the first. But can anybody tell me what the y-intercept would be? What do you think, Ben? 6 is the y-intercept. That's right. So right here, there's your y-intercept, 6. All right. What about the slope? What do you think, Alec? It is 2/3. Notice he was very careful, perhaps, to just say 2/3 instead of 2/3 x. That's a different slope. That means the slope varies, which would mean you'd have a curvy graph instead of a line. So the slope is just m. It's not mx. The way that you can tell what the slope is the slope is always the number that is attached to the x. So let me give you maybe one more example like that. Let's see what you guys think. How about this? Y equals 8 minus 2/5 x. 8 minus 2/5 x. So we'll go in the same order as we did just a second ago. Pay attention to the answer. See if you agree or disagree. Avery, what do you think the y-intercept is? For my blue line. Y-intercept is 8. She is 100% correct. Anybody have any issues with that? No issues at all? Fair enough. All right, Christiana, how about the slope for the blue line?
-2/5.
Very good. Perfectly correct. No questions at all? We're solid? Okay. Oh, question, yes.
So are x and y just variables until you put a number in there?
So yeah, x and y are variables, and if we wanted to, we could plug a number in for x or maybe a number in for y. But if we're going to use slope-intercept form, we're never actually going to do any inputs and outputs. We're never going to plug anything in for x or y. Because with intercepts, we plug zeros in for x's and y's, right?
Yeah.
And to create a table of solutions prior to that, we plug maybe -1, 0, and 1 for the x. We're not going to be doing that here. We're simply going to use the slope and the y-intercept to graph and use these lines.
Okay.
Rocky, go ahead.
Did you just switch the line B around a little bit?
So yeah, the blue line. I was wondering if somebody's going to say that. The blue line is not in y equals mx plus b format, is it?
It's B minus MX.
B plus mx, right? Because you could think of minus as really just adding a negative. Plus a negative is really subtraction. So yeah, I really wrote it as b plus mx instead of mx plus b. So the order there doesn't change the meaning of the b and the mx. Slope is always multiplied times x, and then b is always a constant. So whether I flip the order or not, they still have the same meaning.
Okay.
Yep.
But
Good
you
question.
always know that whichever number's next to X, that has to be M. Okay.
Yep, that's right.
The other one is B. Okay.
That's right. Okay, so let's take a look at example number 1. I think we're maybe ready to do this. Let's talk about the two aspects of number 1 that we need to handle based on what we just talked about. Number 1 says, find the slope and y-intercept of negative 9x minus 3y equals 4. So I want to point this out. I think this is worth thinking about. It wants the slope and the y-intercept. And so what form will tell us the slope and the y-intercept? Y equals mx plus b. Is this currently in y equals mx plus b format?
No.
So we need to solve for y. We need to get the y by itself. So please, just take a moment, get the y by itself, and then we'll try to answer the question. All right, ready, go. Okay, what was your first step here in order to get the y by itself? Colby, what'd you do?
I added 9x to both sides.
Okay, so Colby added 9x to both sides. So when you do that, we would end up with negative 3y equals 9x plus 4. Make sense?
Yes.
Okay, so we're getting there. Christiana, you have the next step?
Yeah.
Go ahead.
So you are going to divide by negative 3
Okay,
from both sides.
okay. I'm going to make... Go ahead.
Okay, then you would get y equals negative 3x plus 4 over 3.
Really close.
Net minus 4 over 3.
Yeah. So y equals negative 3x minus 4/3. Let's just stop right there for a second. Any questions? Yes, Ellie, go ahead.
Why is it minus?
You're talking about the 4/3?
Oh, okay, never mind.
Positive divided by negative is negative?
Yeah.
Question, Jay.
So, I did it a bit differently.
Okay, what'd you do?
I added 3y.
Sure, yeah.
4.
And then subtracted 4.
Mhm.
That
I
works
got
too.
The same thing.
Totally fine. Yep, that's a valid way to do it, definitely. Anybody else? Questions on how to get the y by itself? Okay, now remember that was not the point of it. The point was to identify the slope and the y-intercept. So Amelia, what did you think, what did you find the slope to be?
I think the slope is negative 3 over 1.
Slope is negative 3 over 1. Totally agree. She's getting that from right here. The number attached to the x is negative 3. Now,
Negative 3.
yeah, you could just put negative 3. Now she's putting the negative 3 over 1, probably so you can clearly see the rise and the run, right? The change in y over change in x. That makes perfect sense. Definitely, I like that negative 3 over 1. But if you put negative 3, obviously numerically that's the exact same thing. Okay, so then, Evan, what did you have for the y-intercept?
Negative 4 over 3.
Y-intercept, negative 4/3. I agree with that as well. We doing okay? Yeah? Okay, awesome. Let's move on to number 2. So number 2 is really just the other side of the coin from what we did in number 1. So in number 1, we had an equation and we were asked to find the slope and the y-intercept. Here in number 2, if you look at it, it says, write the slope-intercept equation of the line, and then they give us the slope, and they give us the y-intercept. That make sense? So see if you can take the two facts that they gave you and put it together to find the slope-intercept equation of the line. Okay, so slope-intercept form, of course, is y equals mx plus b. So based on that, Hunter, what did you have for the answer to this one?
Y equals negative 5 over 4x plus 6.
Okay, Ellie, did you agree with that?
Yes.
You do agree with that. How about the rest of you?
Yes.
Good. That's definitely correct. So we want to be able to take that information, put it together to find our slope-intercept equation. Okay, moving on to number 3. Okay, so number 3 says, write the slope-intercept equation of the line graphed below. So this, obviously you can see that red line going through there. This is a little different than what we just had. This one gives you the same information, really, just in a different format. So take a minute. We're trying to look for the slope-intercept equation of the line. So the answer to number 3 will look a lot like number 2, won't it? Maybe some different numbers, but it'll look very similar. But you're going to get your information in a little bit of a different way. I'll give you a moment just to figure that out. See how you do.
Oh, my dad writes comments times like that.
Like that, I write.
Okay, ladies and gentlemen, let's take a look at number 3. Hey, guys. Thank you. All right. So slope-intercept form is y equals mx plus b. Hey, guys. Ladies. Thanks. So in order to handle this, we need to know what the m is. We need to know what the b is. So to me, the easier thing to find is probably the b in this case. So I'm just going to look for where the line crosses the y-axis. And it looks like it's right there at 2, correct?
Yes.
So I'd say b equals 2. I'll use that here in just a second. But I got to find the m before I can finish this, right? In order to find the m, I need to find 2 points that are exactly on the line. And so I would say that this point right here, the y-intercept obviously, that's right on the line. If you go down, you look at this point right here, that's not on the line, is it? I don't think so. What about this point right here? That point's not exactly on the line either. Finally, when we get down to here, doesn't that point appear to be right on the line? Okay, so what I'm going to do now is count off my rise and my run between those 2 points. So the rise would be represented by that line, and the run could be represented by that line right there. Just make a little triangle, a little slope triangle, and we're going to figure out our rise and our run. So the run is how far?
2.
I'd say the run is 2. I want to be really careful with the rise, because is this line really rising?
No.
Isn't it really dropping? So whenever a line is dropping or decreasing from left to right, we have to really consider that the rise is not positive, but negative. So the rise really should be -3. Does that make sense?
Yep.
You can always tell when the rise is negative, when the line goes downhill from left to right. It decreases. Okay, so that means my slope is equal to rise, which is -3, over run, which is 2. Put it together with y equals -3/2 x plus 2. Any questions? Same information, just presented in a graph instead of in a sentence, right, with numbers. So, okay, good deal. Let's move on to number 4. So, with number 4, notice what it tells us. It gives us a very specific method to use. It says use slope-intercept form. And so that means if we're going to graph this line, we need to put it into slope-intercept form first. Is it right now in slope-intercept form?
No.
How do you know that it's not?
Because the y and the x are in the same.
Yeah, y is not by itself. There's x's and 5s and 2s and all kinds of stuff with it. So our first task then is to try to get the y all by itself so we can then use slope-intercept form. And then I want to do the graphing of it with you. I'm guessing that some of you, maybe most all of you, have done this before or seen this before. I want to show you what I'm expecting on something like this. So we'll take a minute at the end to do that together. Right now, just solve for y. So Ben, if I was going to take 5x plus 2y equals 6 and solve it for y, what would you do first?
Subtract 5x from both sides.
That makes sense. That will work just fine. So I'm going to write it like this. 2y equals -5x plus 6. I could write it as 6 minus 5x, but I'm shooting for that y equals mx plus b. So I'm going to write it like that. What would be your final step?
You divide both sides by 2, so it's -5 over 2 plus 3.
Don't forget the x.
Oh, well, -5 over 2x.
Yeah, the x has to be there, but there we go. All right, so once we get here, we want to make sure we understand what is what this actually tells us. Remember, this is called slope-intercept form, so it tells us the slope as well as the y-intercept. So, Danny, what do you think the y-intercept is? I agree. The y-intercept is definitely 3. And then, Sam, what do you think the slope is?
-5 over 2.
I agree with that as well. So, what we're going to do, or I'm sorry, did anybody have any questions on that? That go okay solving for y?
Yes.
So what we're going to do now is we're going to try to graph this. And this is what a lot of folks have done in the past. Let's make sure that we're really good at this. Whenever we're using slope-intercept form, we are always going to graph the y-intercept first. It's going to be our starting point. So here's how this would look. Y-intercept of 3, as was mentioned, will be 1, 2, 3. Getting a y-intercept right about there. Guys, girls, does that make sense to everybody?
Yes.
Y-intercept right there. So then, how many points do I really need to graph a line?
2.
I only need 2. So what I'm going to do is I'm going to use my slope, and I'm going to count that slope off to get my second point. And then really I'll be done. So my slope is negative 5 over 2. So that means my rise will be negative 5, and my run will be 2. Here's what I want you to do. Here's what I would expect on a quiz, test, whatever. I want to actually see you counting off your slope. Here's how you would represent that. My rise is negative 5. So starting at my y-intercept, I'm going to go down 5. So I'm going to go down 1, 2, 3, 4, 5, right there. Do you see I'm putting a little dotted line in there? And then I'm going to run 2. So that would be right 2. So down 5, right 2. So 1, 2. It's a little slope triangle. I want to actually see that written on your page. What I can do at this point now is put another point at the end of the slope triangle right there.
This one you want to say.
Yep, I want to see the little red slope triangles. Well, they don't have to be red, but mine are. And I could keep going with this slope. I don't have to, but I'm going to go down 1, 2, 3, 4, 5, right, 1, 2. So I'm putting in my little slope triangle. It's just indicating that I know what the slope is doing. I know how it works. Once I've done that, I really only have to do one of them, don't I? Mm-hmm. I can do more than one like I did there, but just have to do one at least. Now I can, draw a line between my points and get something like, oops, let's try that again. There we go. Do your best to connect them. I'm not going to get out the ruler and say, oh, you were off by a millimeter. As long as you got your points labeled there, the line, mostly connects the points. We're good, right? I'm not going to get on you to write the equation on the line. I know some of you are used to doing that. If you do that, that's fine. I'm not going to get too upset if you don't. All right. So what do you guys think? Any questions, concerns, worries of any kind? You doing okay with that? How many of you have seen that before? A lot of you have, right? Good number of you. Okay, cool. All right, so that was example number 4. Let's go ahead and move on to number 5. So guys, can we do just a quick review? Let's remember this from last chapter. If you've got 2 lines and the lines are parallel, the slopes are what?
Same.
Slopes are the same. So slopes that are equal mean parallel lines. What if the lines are perpendicular? Their slopes are opposite.
Reciprocal.
Reciprocal, yes. So you flip the fraction and you change the sign. But what if the lines are neither parallel nor perpendicular? Then the slopes are
Neither.
neither or what?
The same or opposite reciprocal.
Yeah, so they're different, right? But they're not opposite reciprocals. Right?
Yeah.
Yeah. They're different. But remember opposite reciprocal slopes, so they're different, but that's a very special
I meant
difference.
like they're not either. That's
Right.
what I said.
You did say it. I just said it the other way. All right, so please take a minute to look at number 5. Let's decide whether those lines are parallel, perpendicular, or neither. Okay, ladies and gentlemen, I think you are probably pretty close to being done. So, in our little review in example number 5, I asked you about parallel lines, perpendicular lines, or maybe neither. And in every case, you all referenced the slope, didn't you? The slopes are this, the slopes are that, whatever. So looking at the first line up here, y equals negative 2/3 x plus 3. Right now, do we know the slope of that line?
Yes.
We do. What is it?
Negative 2/3.
Yeah, it's right here, negative 2/3. So I would say the slope of line 1, so I'll just put M1 equals negative 2/3. What is the slope of the other line? Do we know that right away?
No.
What do we have to do in order to get it there? What do you do? Just say it.
Isolate the y.
Yeah, isolate the y, also known as?
Put it in y equals mx plus b form.
Yes, that is correct. So
What is that? Slope intercept. Sorry.
Slope-intercept, yep. 3x minus 2y equals 14. So if I'm going to try to put this into slope-intercept form, Rocky, what would you do first?
I would 14, I would do 14 minus 3x divided by.
Okay, so you subtracted 3x
Yeah.
from both sides, hopefully. So now you've got negative 2y equals 14 minus 3x. And then what would you do?
Divide by -2.
Okay, so we divide both sides by negative 2. So when I do that, I get y equals negative 7. And then, of course, a negative divided by a negative?
Is a positive.
Correct. So plus 3/2 x. So what is the slope on line 2?
3 over 2.
3 over 2.
Which is the opposite reciprocal of negative.
True. Very good. So what's your final conclusion?
Perpendicular.
Perpendicular. Yes.
Thank you.
Very good. Perpendicular lines, because those slopes are opposite reciprocals. I think we're good. All right. We're going to finish up this section with number 6. Before we do that, though, any follow-ups on that one? All right. Take a look at number 6. It's an application. So let's read it together. Let's try to understand what's happening conceptually. Let's not get too stressed about the math yet. We'll get to that in a little bit. But this says to promote group sales. So groups being more than just one or two people, right? So to promote group sales for an African safari, the tour company reduces the regular ticket price of $15,850 by $75 for each person traveling in the group. Can anybody explain what they're doing?
We're lowering the price of being there.
Lowering the price based on what?
How many people are in your group?
Yeah, so big group means the per person price will be lower. Small group, the per person price will be higher. So you'd be encouraged to get all your friends and family and whoever might be interested to sign up with you, right? Because then the per person price would be as low as it could be based on how many friends and family and people you get to sign up, right? Does that seem like a logical thing for a company to do?
Yeah.
More people sign up, the better, right? So you entice them by reducing the price a little bit, but then you get a lot of people, it makes up for it, right? You get a full trip. Full trip is better than an empty trip, isn't it? Okay. Does that make sense? Do you see logically what's going on? Let me know if any of that wording is confusing, or if you have any questions. Let's look at some key words then. So, what does the tour company do to the regular ticket price? Lowers it. They reduce it, don't they? Mathematically speaking, what does reduces sound like to you? Subtraction, right? If we take the price and reduce it by a certain amount, I'd be subtracting off the price, wouldn't I?
Yeah.
Okay, so the regular ticket price is $15,850. I'm going to be reducing it. I'm going to put those together in a box. I'm going to reduce it by $75 for each person traveling in the group. So let's just talk about this. What if there are 2 people traveling in the group? What would be the reduction in price per person?
75 times 2, which
I think it'd be times 2. You're thinking times 1?
150.
For each person.
For each person, yeah. So if there's 2 people traveling in the group, I'd say
Then it's 75 times 2.
75 times 2, yeah. So you'd drop 150 off the price, right? What if there were 10 people in the group? How much would they drop off the...
750.
Yeah, 75 times 10, which is 750. The truth is, when we start to swing around to question A says, write a linear equation that gives the per person cost if P people travel together. So how big is our group? Is it 2 or 10?
We don't know.
What is it? P, right? So there's P people traveling in our group. It could be 2, it could be 10. We have no idea. We know that that's our group size. So can anybody think of, it wants to know a linear equation for the per person cost. So since we're talking about cost, can I use the letter C?
Yeah.
Okay, so I'm going to say C equals, what do you think the C would equal? If the regular price was $15,850, and I'm going to be reducing that by $75 for each person that signs up, Evan, you had your hand up first. What do you think?
Well, you could do the 15,850 minus 75p.
So he said you could do that. What do you guys think? Could you do that? Does that work? Jake, what do you think?
I think he needs to add a P behind the 15,850.
So like a times P?
Yeah.
So Jake, I'll put this in red. Jake is suggesting a times P. So everything else though you think is good?
Yeah.
Okay. Ben, what do you think?
I think, don't you always have to have a Y and an X?
Well, the C is my Y
The p is that.
and the P is my X.
Oh, I think you should take away the second.
Take away the P from the second. Yeah.
Take away the P from the 75. Danny, what do you think?
I agree with the purple one up there. I would just switch 75 and
Oh, okay. Okay, so
just switch it.
so you're essentially saying the same thing they are, right?
Yeah. Just
Put the
like
P
that.
with the 15,850, take it away from the 75. Did I say that right?
I would just do negative 75p plus 15,800.
So you 100% agree with the purple. You just think you would prefer the order the other way?
That's what I did, but I thought
Okay.
that was
And
making
no
sense.
P
I did
on
negative.
the 15,000.
Oh, and you're saying no P on the 15,850.
Yeah.
Yeah, no P.
Okay, fair enough. So let's kind of boil this down to what the correct answer is. Our original answer in purple, as proposed by Evan, is totally correct. Let's talk about why the P does not belong times the 15,850. What this asks us to do is write a linear equation for the per person cost. So if you think about it, what's the original price per person?
15,850.
Yeah, thankfully the original price is not 15,850 times the number of people, right? Because if you do that, like if you maybe had like 10 people going, I think I know what you were saying, Jake, but if you had 10 people going, wouldn't each person have to pay $15,850 times 10? Oh, we're talking about like $160,000 now, minus 750. That's not a good deal. That wouldn't be very enticing. Jake, what I think you did, and you can correct me if I'm wrong, is you were thinking about like the total price of the whole trip for the whole group.
That's what I was thinking.
If you're thinking along those lines, now you're starting to get into what we're talking about. I mean, I think we'd need to make some adjustments yet. But since this only wants the per person cost, we have to go with this right here. Okay. So the final part here, part B, says use that equation that you just found there to determine the per person cost if 8 people travel together. So 8 people, coworkers
Times
apparently. So let's figure it out. What would we have to do if we were going to figure out the per person cost with 8 people traveling together? What do you think, Christiana?
I think you have to multiply negative 75 times 8.
Okay, so, but use the equation. Like, what would I be doing with the 8 and the P
Okay.
and all that stuff?
C equals negative 75 times
C equals negative 75.
times 8
Yep.
plus 15,850.
That makes sense? What did she really do? Like, what, using the lingo that we've used a lot, what did she do with the 8? Say again?
Substitute.
Yeah, substituted the 8 in for the P, right? Or you could say she plugged the 8 in for the P, right? Same sort of thing. You'd use your calculator here.
600.
So 15,250 would be the final cost. So per person, it would be $15,250. That's still a lot of money, but it's $600 less because you got 8 people to go together. So perhaps they'll be happy with that. So anyways, that is the finish to 3.5 slope intercept form. You guys doing okay?